Section 1.5 has a lot in it. It's going to be on special angle pairs and their relationships mathematically. It's going to be a 2-dayer. So today is going to be most of the notes with a worksheet and then followed by just a little bit of notes and some delta math. So a 2-day section here with 1.5. So let's talk about some of our common angle pairs in geometry. Adjacent angles, adjacent means next to. So basically they share a side and they're just right next to each other. So angle 1 is adjacent to angle 2. Vertical angle, and they don't really have any mathematical relationship. If it just says they're adjacent, all you really know is that they share a side or share a ray that splits a big angle into two smaller ones. Vertical angles, though, are these ones across from each other on an X, so like a pair of scissors. So angle 1 and 2 are vertical angles, so are angles 3 and angle 4. They are congruent, which means their measures are equal. So we're going to put a big congruent symbol right here. So you know that when you have vertical angles, you're going to be setting their measures equal. Complementary angles add up to 90 degrees. They may or may not be adjacent. For example, on this pair, if this is 60 and this is 30, we would have an adjacent pair of complementary angles. So we're going to say that add to 90. Put that in a box. They don't have to be adjacent though. I can put a 50-degreer right here and a 40-degreer down here, and we'd still say that those are complementary angles. They're just not adjacent and complementary. They're separate. Supplementary angles add up to 180 degrees, and if you pull them together and made them adjacent, they make a line. So perhaps this is 120 and this is 60. We would say they are supplementary angles because they add up to 180 degrees. So let's go practice some of this. Let's find some adjacent pairs of angles. They're adjacent when they are next to each other or they share a side. So I think I'm going to start with angle AFB. Right here in green. It does share a side, and let's choose this one. You can see I'm doubling over, sharing that side of FB. And angle CFB. And there's other pairs. I'm just putting, one down there. I don't need to do all of them. Now, verticals are ones across from each other on an X. So it kind of has to be if you make an X. You can't say, well, this is across from this because these sides don't make like an X. They're kind of wonky. So I see an X in here, right here, in purple, that line, intersecting the red one. Those make what I would call an X. The angles across from each other are called vertical pairs. So I have this one over here and this one over here. Those would be called a vertical pair. Angle AFE and angle CFD. Those are a vertical pair. So I know their measures are equal because the angles are congruent, so I could say that's 62 if I wanted to, because they're across from each other on that X. Okay? Another vertical pair would be this guy in green and this big one over here in yellow. Those are also a vertical pair. Complementary angles have to add up to 90 degrees. I can see I have a 62 over here. 62 plus 28 is 90. So a pair of complementary angles would be angle AFE and angle BFC. Supplementary angles make a line together if you pull them together, if they're adjacent, and they add up to 180. So I can see a really clear pair right here. Angle AFE and angle DFE are supplementary. They're also adjacent. So I'm going to put that right here. They are next to each other and add up to 180. Now it says adjacent and complementary. All right. Well, that's going to need a little bit more work because to be adjacent and complementary, remember I said that this guy over here was 62 degrees because it's vertical to this one? That means that these two right here, the 62er in green and the 28er in orange, add up to 90 degrees, and they share a side, and they are neighbors. So we would say angle BFC and angle CFD are neighbors, and they add up to 180, making them adjacent and complementary. So that's kind of a lot. This says, what conclusions can we draw about the angles in this figure and why? Well, I'm just going to put some of them on there, okay? I'm going to say that I know angle 1 is congruent to angle 2. Why? Because I see that single arc in there. They both have a single arc. Remember, we talked about that in section 1.4, that angles marked with the same number of arcs are congruent. I see a glaring vertical angle pair. When this blue line and this red one cross to make an X, I can see that angle 3 and angle 5 are across from each other. So angle 3 would be congruent to angle 5 because they're a vertical angle pair. And there's lots of adjacents up there, but let's find out, how about if I were to claim that there's a pair of angles that are adjacent and supplementary. And I'm not drawing all the conclusions, but I'm going to say adjacent and supplementary. What pair would I be seeing? That they're neighbors, adjacent, and they add up to 180 or make a line together. The pair I see are angle 3 and angle 4. Do you see how when I travel along the angles, I do a 180? So I'm going to say angle 3 and angle 4 are adjacent and supplementary. And then let's just dot, 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 because there's more things. All right, true or false? Must TW equal WV? Yes. Only because I see the single dashes, which means those segments are congruent, their measures are equal. Must PW equal WQ? It looks like they are, but there's no markings on there. Maybe this was 5 and this was 5.01. I don't know until I either see numbers or dashes. Is TV bisected, cut in half? So here's TV. Did PQ cut it in half? Yes. How do I know? Because these are marked as equal. Okay, so yes, true. I should be saying true, false, true. And lastly, is TWQ a right angle? Well, it looks like it. But remember, I need to either see this box in here or I have to be told. So I'm going to say that doesn't have to be true. Okay? And our last pair of angles are called a linear pair. A linear pair of angles are next to each other, adjacent, they share a side, and they are supplementary. Remember, angles can be supplementary without being adjacent. Here's a pair right here, 120, and then up here I'm going to go put a 60 degree here. Do they add up to 180? Yes. Are they supplementary? Yes. Are they adjacent and supplementary? No. They aren't until I put the 60 as the neighbor. Okay, so when I do that, they make a line together and they add up to 180 degrees. So let's do a little better sketch. So they make a line together. So here's my line. Here's my adjacent angles, angle 1 and angle 2. They must now add up to 180 degrees. And they would be called a linear pair. So angle 1 and angle 2 form a linear pair. And that root word means line, 2. So 2 angles that make a line together. So now we're going to move into a little algebra. I'm just going to make sure I didn't skip anything. I didn't. All right. So I've got an angle that makes 2 angles that make a linear pair. Let's go draw them. angle A, so I need an A on here, D, and then I got to shoot off and make a B. There's angle ADB. And BD, well, that C is going to have to go over here, make a linear pair. ADB is 3x plus 14. BDC is 5x minus 2. Find the measure of the angles. Well, because they are a linear pair and they make a line, they must add up to 180 degrees. So linear pairs add up to 180 degrees. And then we pass off to the algebra part of it, right? We combine our like terms, 8x's, 14 minus 2 is 12 positive, equals 180. We'll subtract that 12 because we're on the x attack, so we need to get rid of the plus 12 and then multiply by 8. We'll get 8x is equal to 168. Dividing both sides by 8, we'll get an x is equal to 21. I'm going to go back and read the question. Did it say to find x? No. It said to find the measure of each angle. So the red angle is going to have to be 3 times 21 plus 14. And my blue angle is going to have to be 5 times 21 minus 2. So we'll go do our arithmetic. We'll have our 63 plus 14 for 77 degrees for the red angle. And this one will have, what, 105 minus 2 for 103 for the blue angle. How do I know I did it correctly? When I add the red and the blue, I get 180. And linear pairs have to add up to 180 degrees. Sweet, right? So, next up, what does bisect mean? We've talked about that already. It means it cuts in half or cut into 2 equal parts. Angles can be bisected, segments can be bisected, apples can be bisected, people can be bisected. I guess if I take my little stick man here, cut him right down the middle, I have bisected him. Cut him into 2 equal parts. So this says draw an angle bisector. All right, there's an angle. And then as best I can, I'm going to bisect it. To prove to you that I did, I'm going to put single arcs on here. So that way I'm telling you that the top and the bottom are equal. It says state the relationship between the angles. There's a couple of them. I'm going to just call this angle 1, angle 2. Angle 1 is the same as angle 2, right? I also know that the measure of angle 1 plus the measure of angle 2 equals the measure of the whole way. Well, what should I call the whole way? Let's make this an A, let's make it easy, and a B, and a C. That's my angle that got bisected. Measure of angle A, B, C. So to bisect means to cut into 2 equal pieces. When angles are bisected, the 2 smaller ones are equal to each other. So let's go practice. We have ray MK bisecting. So that ray is going to cut angle LMN. I got to go draw that. So let's go make an angle LMN. L, vertex has to be the M because that's the middle letter. And then N. Now what do I have? I have this ray bisecting. So I'm going to, as best I can, try to show that it's cutting it into 2 equal pieces. And I actually think I'm going to do that a little bit better and a little bit more this way. Okay, so that's MK. So I've drawn a picture of the situation. And it says, the measure of angle LMK is x plus 2. L into M into K, that's this top one. So I'm going to go put an x plus 12 in there. The measure of KMN, so from K into, that's the bottom one, equals 5x minus 8. You might say, LaRude, I know they add up to the whole way, but I don't know the whole way. That's where this word comes into play. Because to bisect means it cut it into 2 equal pieces. So we will set x plus 12, the green piece, equal to 5x minus 8, the degree measure of the blue angle. And then we've got that variable that needs to move. 1 is less than 5, so I'm going to choose to get rid of the 1x. It's going to leave me with a 12 equaling 4x minus 8. My variable's now on the right, so I'll add that 8, and I'll get 20 is equal to 4x, or 4 times x. So to undo the division, multiplication, I divide. I get x is equal to 5. Back up to the question. What is the measure of each angle? So I'm not done. 5's got to go in here. And I'll say 5 plus 12 is equal to 17 degrees. And that would be the measure of angle LMK. Bam. Excuse me. I would have 5 times 5 minus 8 is 25 is 17 degrees, which equals the measure of angle KMN. How do I know I did it correctly? Because I know the ray got the angle got bisected, so those two angles better be equal to each other, and they are. Now my picture's obviously not drawn to scale because my angle would have been a 34-degree angle that got cut in half. But again, my sketch is just to help me. I don't know the answer till I'm done. So you won't have a picture drawn to scale when you draw that. So today's assignment is worksheet 1.5. If you're absent, it's linked on the slide. Also linked, perhaps or maybe, is some help for that in Schoology. I think I might have some help for that worksheet. If not, just ask for help. Tomorrow, more 1.5. We won't be moving on. All right, have a good one. I am Mrs. LaRude, and you are not.